Basic Electrical Fundamentals, Unit 1. For electric circuit, we define conductance. For magnetic circuit, we define permeability. Those magnetic materials are made suited for making armature and transformer cores which have high permeability and low hysteresis loss. Reluctance S is defined as the opposition of magnetic flux in a magnetic circuit. Total number of magnetic lines of force in a magnetic field is called magnetic flux. Unit is Weber. Reluctance S is equal to ampere turns per Weber, AT per Weber, that is 1 upon Henry. Self-inductance, magnetic flux into current, that is equals to 2 millihenry in this example. The direction of DC and magnitude of current in DC do not change. Simply, both positive and negative terminals of a battery are always positive and negative. Therefore, the current that flows always in the same direction between both terminals. For example, fuel cells, batteries, and solar cells. This is due to fixed polarity. Here, Vrms is equal to 0.707 of maximum voltage. I average is the average taken of instantaneous current values. RMS stands for root mean square. This value of current is obtained by squaring all the current's values, finding the average and then square root. That is, effective value of current is RMS value of current. In a sinusoidal wave, I average is always less than I RMS. For a rectangular wave, I average is always equal to the IRMS. Therefore, heating effect is constant. The SI unit of magnetic flux, that is Weber or Tesla meters square, named after the German physicist Wilhelm Weber. EMF, electromotive force, the electric potential produced by either an electrochemical cell or by the changing of magnetic field. EMF as voltage. 1 volt is equal to 1 joule per 1 coulomb. A volt is a unit of EMF that measures the potential difference in electric potential between 2 points as voltage measured in volts. In BH curves, B stands for magnetic flux density, that is BH curve, hysteresis or magnetization curve. Graphical representation of magnetic property of material relating magnetic field strength H and the magnetic flux intensity or density, that is B. That is B is equal to flux per unit area, that is phi per meter square, that is 1 Weber per meter square is equal to 1 Tesla, and MMF is magnetomotive force. H is the magnetizing force, ampere meter. Hysteresis curve, BH curve, is magnetic flux density, B lagging behind H, that is field strength. SI unit of actual permeability of free space is H, Henry per meter. Constant between B and H. Magnetic flux lines passes through iron because of the permeability of iron is much larger. MMF of Magnetic circuit is analogous to EMF in magnetic electric circuit and may be considered the factor that set up the flux. In BH curve of soft iron will not be a straight line. Soft iron is a ferromagnetic material that is commonly used in electromagnets and magnetic circuits due to its high magnetic permeability. It has a nonlinear BH curve due to its high saturation magnetization. The direction of induced EMF can be found out from Fleming's right-hand rule. Len's law suggests that the direction of induced EMF opposes the change in magnetic flux. The negative sign in Faraday's law can be relating to it is equal to minus n d phi by dt. Len's law gives the direction of induced EMF with respect to change in magnetic flux, but Fleming's law gives the direction of induced EMF more accurately. Soft iron has the least hysteresis loop area because it has low coercivity and high permeability. Hysteresis loop area is a measure of energy loss in a ferromagnetic material when it is repeatedly magnetized and demagnetized. I is equal to Q upon T, that is coulombs per second, and V is equal to J upon Q, that is joules per coulomb. Q is equal to IT, and permeance is reciprocal of reluctance. Conductivity of a metallic wire is its ability to allow the electric charges or heat to pass through it, and analogous to permeability, which is the measure of magnetization produced in a material in response to an applied magnetic field. Scientist Heinrich Rudolf Hertz was a German physicist who first conclusively proved the existence of the waves, which are electromagnetic, and was predicted by James Clerk Maxwell's equation of electromagnetism. The unit of frequency is cycle per second was named Hertz in his honor. Frequency is equal to cycle per second is equal to Hertz. Frequency of a wave is the number of waves that passes a point in a certain period of time, that is in 1 second, that is number of cycles in 1 second is equal to frequency. Power factor of an AC circuit is equal to the cosine of the angle between voltage and current. If two sinusoids of same frequency but different amplitude and phase angle are added or subtracted, the resultant is a sinusoid of the same frequency. Peak factor is equal to ratio of maximum value to the RMS value, and that is equal to 1.414, and form factor is ratio of RMS value to the average value, that is equals to 1.11 for sinusoidal waveform. These are the constants for designing the electrical equipments. In an AC circuit, power is dissipated in resistance only due to voltage drop in resistance. The voltage of domestic AC is 220 volt. It is the RMS voltage of supply. Cos 0 is equal to 1. Therefore, power is VI cos phi, that is equal to VI for resistive load, and for inductive and capacitive load phi is 90, that is phase angle between voltage and current is 90. So cos phi will be 0, therefore power will be 0. So consumed power is always 0 in inductive and capacitive load. power is Vi cos phi, therefore 1840 watts. For purely inductive and purely capacitive circuit, the power factor is 0. The true power equals to 0, that is P is equal to 0. Maximum flux density is equal to phi upon A. So therefore 6000 microtesla. Magnetic circuit have an equivalent to the potential difference of electric circuit. This is the magnetic potential difference which allows us to apply Kirchhoff's law to the magnetic circuit analysis. This is the phasor representation of three-phase voltages. VR as a reference and VB will be the plus 120 or minus 240, and Vy is equal to minus 120 and plus 240. So these are the leading and lagging phase angles between VR, VB and Vy. So the phase sequence is ABC. The maximum value of voltage in sequential order is ABC. This is the three-phase, three-wire system. This is three-phase, four-wire system with neutral. Resistance is not charging or storing element, so applicable to AC and DC also. Capacitive reactance Xc is equal to 1 upon 2 pi Fc. Therefore, Xc is inversely proportional to frequency. As the Xc decreases, the frequency will increases, and XL, that is inductive reactance 2 pi FL, XL will directly proportional to the frequency. XL increases, then the frequency also increases. The pure inductive circuit stores energy in magnetic field and again returns to the source and do not consume power. P is equal to Vi cos phi, and Vi cos of 90 degree is equal to 0. Power is 0. So in the one cycle, T is denoting as a time period of a one cycle, and frequency is the reciprocal of time period. So this is cosine waveform and this is sinusoidal waveform. The phase difference between these two waveforms is 90. An air gap is inserted in magnetic circuits to prevent saturation and to reluctance increment of a magnetic circuit. By inserting air gap or another non-magnetic materials like a fiber plate, thereby increasing amount of current that could put in the coil before we reach saturation. Also, the air gap helps the magnetic flux to expand outside the magnetic circuits. The magnetic effect of current was discovered by Oersted by showing electricity and magnetism were related phenomena. So in this waveform, reference is voltage and current is lagging behind by 30 degrees. So current lags V by 30 degree and voltage leads current by 30 degrees. And in this waveform, current leads voltage by 60 degree and voltage lags current by 60 degrees. And this is the in phase waveform. Voltage and current are in phase. This is applicable for the resistive load. These are the circuit diagrams and phasor diagram for resistive circuit and purely inductive circuits and purely capacitive circuits. In resistive circuits, you can see voltage and currents are in phase, and in purely inductive circuits, current is lagging behind by 90 degree, and in purely capacitive circuits, current leads voltage by 90 degree. due to all impedances are not equal, therefore unbalanced star load, then all values will be unequal. If 8 plus J6 for all loads, then balanced star load, then all values will be equal. This is for balanced, and this diagram shows for unbalanced star load. For the conversion of star to delta, that is resistance between B and C is equal to resistance of B plus resistance of C plus resistance of B into resistance of C upon resistance of A. This is the circuit analysis for star and delta. So the equivalent resistance across X and Y is 2.38 ohm. Delta connection, that is mesh connection, is that closed loop which is planar, and this is resistance between A and B is equal to 29 ohm. In delta connection, VL is equal to VPH and IL is equal to root 3 IPH. In star connection, VL is equal to root 3 VPH and IL is equal to IPH. So here L is stands for line and PH stands for phase. A generator having two or more electrical windings which are separated by equal electrical angle generates a polyphase electrical system. The electrical angle or displacement depends upon the number of windings or phases. In three-phase system, the generated voltages are separated from each other by 120 degrees. So the total summation of this voltage is always 0. That is vector addition. Voltage between free ends to line is VL, and voltage between across each coil to phase voltage. Inside magnet, the field lines moves from south to north pole and outside magnet north to south pole. The direction of rotation of electric motor's coil is determined by the Fleming's left hand rule. We can induce the current in the coil by moving the coil in a magnetic field. We can have addition and subtraction in the rectangular form directly, and angular frequency, that is omega, is equal to 2 pi f radians per second. So here angular frequency is 31.4 radians per second. This sine wave is said to be lagging because it passes through the zero following the other. Hence, it crosses zero after the first wave. Therefore, it is said to lag. The time axis while measuring an AC sinusoidal voltage or current represents the phase angle when converting it into a phasor, that is magnitude and angle, phase angle. Here 6 is the magnitude of voltage and phi is the angle between this reference and 6 voltage or current values. The length of the phasor arrow represents the magnitude of the quantity, whereas the angle between the phasor and reference represents the phase angle. Ohm's law, V is equal to IR, that is analogous to force is equal to flux and reluctance. For magnetic circuits, MMF is decreased directly proportional to decreased magnetic flux, whereas S is constant. So force is 1580. Phi is equal to BA. B is equal to phi upon A, that is 1.6 Tesla. DC generator generates electricity using the principle of Faraday's law of electromagnetic induction. When a conductor is placed in a varying magnetic field and EMF induced in it. According to Faraday's first law of electromagnetic induction, an EMF induced in a conductor when it cuts the magnetic flux of a magnetic field. If the two ends of a conductor are connected to an outside circuit, the induced EMF causes current to flow in the circuits. According to the Faraday's second law of electromagnetic induction, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux linkage, that is E is equal to minus n d phi by dt. D phi means that is change in magnetic flux with respect to time, and n is the number of turns of windings. A minus sign is denoted for the Lenz's law for direction of induced EMF, that is opposite to the very cause for the production of induced EMF due to this changing magnetic field. The law of conservation of energy, that is mechanical to electrical, that is dynamo, and electrical to mechanical, that is motor. The induced EMF persists only as long as the change in magnetic field continues, and polarity of the induced EMF is given by the Lenz's law. Ampere's law correlates with the magnetic field induced in the coil. By-Savart's law describes the magnetic field generated by a constant electric current. Fleming's right-hand rule gives the estimation, that is, in which direction the current will flow. Galvanometer measures the amount of induced current flowing through the circuit. If a current carrying conductor connected to a battery, the pointer of galvanometer fluctuates and points to the amount of current flowing. Self-inductance of a coil is said to be 1 Henry if an induced EMF of 1 volt is set up in it when the current in it changes at the rate of 1 ampere per second. It is the induction of voltage in a current carrying conductor when current in the conductor itself is changing, that is as L is equal to 1 Henry when 1 voltage is set up due to the changing in current 1 ampere per second. Self-induction of a coil tends to take care of the magnetic field linked with it and opposes any change within the flux by inducing a current in it. Therefore, it is called as a inertia of electricity.